Okay, so let us just move forward in our session. See, yesterday what we did is we have formatted one disk and we have mounted it to a folder, and if I do dffnst, we see that our Java folder that we created, and we have mounted it to SDB1 partition of a hard disk. But what if tomorrow I want to increase the disk space? What are the options available? Because my hard disk that I have already attached is of 8 GB. So one more option what I can have is I can attach a bigger hard disk. Let us suppose I attach a 32 GB of hard disk, and what I can do is I can copy data from /java to, I will mount it to Java new. Let us suppose that I create a folder called Java new, and I mount that 32 GB of hard disk to that Java new folder, and I will copy data from this 8 GB to 32 GB, and then I delete this hard disk, I delete this partition, and I rename the Java old to Java new to Java. That is one option available, but we cannot keep on doing this in production, right? Because application might be running in Java. Okay, we cannot stop the application and then copy all the data to new disk and mount it and then start the application. So to overcome this problem, we have come up with a concept called LVM. Okay, let me share my PPT. So what is LVM? LVM is Logical Volume Manager. With this, we get a lot of advantages. Like we can dynamically expand or compress. Generally, we go for dynamic expansion. We don't recommend compressing the disk size, and we can increase the space to how much ever is required using LVM. So where is this useful? You might get scenarios in your work life, like somewhere some one VM data is full, storage is full, and you have to increase the storage. For example, you can even go as simple as in DevOps you will have Linux agents. In agent, if your this one is full, okay, data is full, then you will have to fix it before you can run pipelines. Your pipelines will break. So in what happens in LVM is we have one, remember what we did, we had SDB 8 GB, and then in LVM what do is we create a physical volume. We make it, we call it PV. We create a physical volume, we attach a SDB, we call it a physical volume, we create a physical volume out of it, and then we create a volume group. Let us suppose the name of the volume group is Azure. We create a volume group called Azure, and that volume group is 8 GB. Now from this volume group we can create logical volumes, and we can mount it to different folders. For example, I create logical volume of 2 GB and mount it to app folder or Java folder. Like I create a logical volume called app and I can mount it to Java folder, and I create a logical volume called data and I mount it to data folder if I want to keep my app and data separately. Okay, so let us see how this works and how is this advantageous. Okay, and since this is 8 GB, I can split it and give it to different folders, and we can extend. Okay, now let us see practically how this is happening. Okay, now let us suppose I don't want to format it directly and mount it to Java. I will create a physical volume out of this, then I will create a volume group, and then I will create a logical volume. You are getting the steps right as per PPT. So
but what is the difference between this space and the physical volume?
Which phase?
Like now we are attached 8 GB, right? Now we are connected to physical volume. What is the difference between normal volume and physical volume?
Yeah, so in this volume, in normal volume, suppose I am creating one part, I am creating one logical volume of 2 GB, and in my volume group I have 8 GB of space. Okay, now if I want to extend this, suppose I want to extend Java, then what I can do using simple commands, I can take the volume. So after creating a 2 GB of app logical volume, after getting 2 GB of data logical volume, I'm still left with 4 GB, right? Because my volume group is of 8 GB. So if there is space with my volume group, I can increase the Java or the app volume group and data volume group. Now suppose I run out of this volume group also. For example, I run out of this 8 GB, entire 8 GB. Then what I can do, I can attach one more disk. I can call it again SDC, maybe I don't mind the spelling mistake, and I can create a physical volume out of it, and then I can add that to volume group, so that my new volume group is 16 GB, and I can then increase the logical volume of both. I can make it 8 GB and 8 GB.
You would say initial physical volume is it's the same, correct? After creating a volume group, only it's going to change behavior, correct? But
Yes,
initially
we are going to create a volume group. It's like pool of hard disk. You can attach n number of hard disks. Suppose you run out of 16 GB also, the 8 you run out of it. What you have to do, you have to attach one more disk. It will be called as SD, A, B, C, D, E, SDE. Okay, and then create a physical volume out of it, add that SDE to volume group, and then you can increase it to 4 you can increase, you can make it 12, you can make it 12, or you can increase 8 here if you want more, or if you want data to be increased more, you can make it. So this is the advantage. This is what is a best practice we follow in industry. Anywhere you go, even this VM, if you see here, let us suppose whatever VM you have booted, if you go through DFF and ST, you see that this root is a type of XFS partition, and it is a LVM type of partition. Root is always LVM type. If you see here LSVLK, if you do, sorry, you see that your root is a LVM type of partition. So if you run out of space in your root, what do? All you have to do is, root is, since it is an LVM, so what is the logic volume name? It is CL-root is a logic volume name. Okay, you need to see what is the volume group, and you can attach a disk to that volume group, and your root partition will be increased. Getting it?
got it.
Yeah. So let us go step by step. First, let us see how do we create a physical volume. What is the first step in the PPT? The first step is creating of physical volume. Okay, we attach a disk, and then we create a physical volume. Then we create a volume group. So already there will be volume groups. So you might encounter scenarios where already volume groups are present. You just have to manage those volume groups. But let us see how those are created, so that you will have more better understanding when you are working with them. Okay, now what we have to do, the first step is always ls-blk check what are the disks available. So what I will do is, I'll unmount Java. I will use SDB1 as my first disk, and then I will use SDC, which I have attached and kept it. Okay, for that I just have to, for unmounting, I have to go to fstab and remove this entry, because if you don't remove this entry, what will happen? In fstab, there is an entry that you mount that UUID to /Java at some point of time, like while booting. If while booting it does not find the UUID, the disk or the folder, then your booting process will not happen. Your Linux system will not boot. In those scenarios, if you encounter such scenarios where you made some mistakes in fstab and you're not able to boot it up, you can go to run level 1 and change this fstab. So maybe I'll not cover that, because that is very unlikely that you'll encounter those scenarios, because you have to do it properly. So if you want to check, you can go and read about it, how to get into run level 1 and change fstab entry if you face errors in fstab while booting. Okay, now let us focus on formatting it. Okay, now what I will do is, I'll unmount umount /dv/sdb1. I have unmounted it because I want to reformat it. Okay, with LVM type of partition. I don't want a normal type of. So what I have to do, fdisk /dv/sdbb. Okay, I'll create a new partition. You remember this? If I press M, I'll get help. I can create a new partition. Okay, and I think I need to overwrite. One second. I need to delete a partition. Deleted. Then I have to create a new partition, primary partition, default, and first sector. I'll format the entire disk. You want to remove? Yes, it's already there, so it is asking. Now what I will do is I need to specify the type. So here I need to type. If I give M for help, I need to type a command called T. Change partition type. I want to change the partition type to LVM type. So here I can press capital L to see what are the types available. So these are the types of partitions I can have in Linux. Okay. So what we want this LVM type, that is 8E. Okay. So I will format this hard disk with LVM type of partition and I'll write it to the disk. Okay, I think it's too busy. We need to reboot once. 1 second, I'll just reboot it. For time being, let me create with SDC, which I have added. Then we can reboot and take it. So SDC is there. If you see, fresh disk is there. Yeah. So let us format this fdisk/dev/sdc. Okay, I will write a new partition, primary partition, partition number default, first sector default, last sector default, and I'll change the type to 8E. LVM type I want to change it to 8E. Okay, and I'll write it. Okay, now my disk is ready. If I do ls-blk, I will see that SDC1 is created. Okay, now what I have to do is I need to create physical volume. So every time you attach a disk, in case of LVM, the first step is to always create physical volume, whatever disk you have attached. So the command for creating physical volume is pv create. Let me just clear this, make it big. Yeah, pv create /dev/sdc1. Okay, so we have created a physical volume. So this is common every time we attach a disk. The first thing what we have to do is we need to create a physical volume. Okay, next is we need to see if it is created properly or not. So for that we can do pv scan. This is a command. It will scan and it will tell you what are the physical volumes that are already created. So here we should get our SDC1. SDA2 is already created, which is being used by CL for root. We saw that root is also using LVM. So, but this is what we did now. dev/sdc1. Okay.
One
now
question. See, we created a
yeah.
physical value. Can we use without attaching to the value group, or how this be in a physical location? See, we attached 8 GB. So okay, like if you don't attach to value group, how behavior of this one in the Linux box?
We won't be able to do anything. We have to create a volume group, or we have to attach it to a volume group to be able to use this. And
okay.
then,
but now we can't even we can't use as a normal disk as well, right? Because it's considered as a value, correct?
Yeah, it is considered as LVM partition. So we cannot use it as normal disk also. It is wasted if we don't do anything.
Okay. Okay.
We can reformat it with normal type of partition, like what we did yesterday. Without pressing the T, if you give normal partition, again reformat it, you'll be able to mount it to some folder and use it normally, like however we did yesterday.
Okay.
Okay, so when you're going with LVM, you format it with LVM type of partition, and then we create a physical volume, and then we create a volume group, or we can attach it to a already existing volume. We'll see both. Let us create a volume group for us. So command is vg create. Let us give volume group called Azure data. Okay, we want this to be or something. Okay, and then we need to give what we are adding, what are the PVs we are adding to volume group. So the PV is SDC1. Okay, it will create a volume group with SDC1 disk. Now tomorrow morning, if we attach a new disk, we will not do VG create. We will do VG extend. We want to extend the volume group, that I will show. So now our VG is created. All we have to do is VG display -v. It will show us our whatever we have created. If you don't give -v and name, it will show all the VGs available. It will show us the root VG also that root is using. I will show you that also. So we get VG display. So here, what are the important things to see? We can see here what is this free space, because next time when I add, if I need to able to see that what is, if free space is there or not. If free space is there, I need not add a new disk. Okay, in VG, in volume group, if we have space left, we can create or extend logical volumes. Okay, you just follow the hierarchy. It is always physical volume, and then volume group, and then logical volume. So we have created this physical volume and this disk are interlinked. We have to anyway format it with LVM type. Till now we are clear, right? First two steps is, this is attaching the disk, this is formatting the disk with LVM type of partition, and here we are either we are adding this. We can do two things here. Either we can add physical volume to volume group, or we can create a new volume group. So now we have seen creating a new volume group called Azure Data, and that is our 8 GB free space. We can see here. Okay, and we can see that what are the physical volumes which led to the formation of this volume group. You understand? Like when I say volume group, it is a group of volume. It will have multiple physical volumes under it. This is like pool of hard disk. Okay, now what I have to do, next step is I need to do LV create. I need to do logical volume creation. So what I can do, again, commands are almost similar. All you have to do is you need to remember what you are creating, and you can use a command like LV create, VG create, PV create, LV remove, PG remove, VG remove if you want to remove it. Okay, now we'll use LG create -L. L is the size, how much I want to give. Let me give 2 GB. So I need to give plus, no, I need to give 2 GB, 2G -N. I need to give the name of the LV that we are going to create. Let me give Java. Okay, and then I need to give the VG name in which I am going to create it. Okay, so it will create a 2 GB of logical volume. So this is the volume that we are going to use. This is the logical volume. Okay, now once the logical volume is created, what is the thing we have to do? We have to, before mounting, what did we do in case of normal hard disk mounting? Before mounting of like disk to, after creating partition and before mounting to Java folder, we perform one more activity. Anyone remembers?
Formatted, correct?
Sorry?
We formatted.
Correct. So this logical volume should be formatted before we mount it. And the advantage with this is we can format different logical volumes with different file systems. So I can format one LV with ext4, another LV with ext3. So, and likewise. So let us format it. So command will be same ext4. There we gave /dev /sdb1 sdc1. Here we are going to do /dev /volume group name, that is Azure Data, /lv name. LV name is Java. Okay. Now this will format our logical volume. Yeah. Once this is done, once it has formatted our logical volume, we can mount our logical volume to any, for example, I will mount it to Java now. Okay, SDB1 is mounted, so I will do umount /dv /sdb1. Okay, so it is unmounted. I will mount my LV now. So for that I have to do mount /dev / Azure data / Java to which folder? /Java folder. Okay. Now if I do df-ht, you can see my Java is of 2 GB and it is LVM type. I mean, you can see mapper here, you can make out that it is LVM type, or you can do ls blk to check which type is that. In this you can see it is LVM type, and in SDC we have created one Azure data -Java. It gives volume group hyphen logical volume name. Okay. Now let us create one more logical volume, because if I do VG display, I'll check what if new folder. I want to create a data folder, mkdir/data. I want to have it's already existing, so database. Okay. Now I want to keep my database in this. So what I will check first is, do I have space in my volume group? So this is what CL volume group. This is for root. Does it have space? No. So I cannot create a LV because we don't have space in this volume group. I will check if this volume group has space. Yes, this has 6 GB of space because 2 GB is already allocated to Java. Okay, so you're getting right. So where are we here now? We created physical volume and we formatted with LVM type of partition to the physical volume, and then we created a volume group of 8 GB and we named it as Azure data. Okay, and okay, let me just rename it so that you don't get confused. Azure data, and then we created a volume called Java database. So yeah, so we have created one volume group called Azure data, and then we created one logical volume called Java and mounted it to Java folder. Now we want to create a logical volume called database. So already out of 8 GB we have used 2 GB, so 6 GB is left with volume group. We will create one more. So out of that 6 GB we will create one more logical volume called database with 2 GB. So we will use the same command. Since space is there, we can use the same commands to create how many our logical volumes we want. Now we have to do is lv create. I want to again create lv create. Okay, -l and the size. Let me give 2 GB or 3 GB of it. 3 GB. Okay, and then name will be data, and then I want to mount what is the volume group I am taking it from? Azure data. Okay, now I am creating an LV of 3 GB and I will take it and I will mount my database to it so that I can keep my database files of 3 GB in this. So what is it? Next I have to format it, mkfs.ext4 then /dev/ Azure data /data. Data is my logical volume name, and we have to format it with ext4. So it will do the formatting in ext4 file system, and then we need to mount it to mount /dev/ Azure data /data to /database. Okay, now what will happen? Now you can see here that in database there is a 2.9 almost 3 GB of data is available, and if you do ls-blk you can see that in SDC we have two LVMs created of 2 GB and 3 GB, and they are mounted to Java and database. Okay, now if I do VG display volume group display, okay, see in whenever you are working you might not get into the most number of level you get into is I think volume group. Below that I think physical volume you did not check. Only time you check physical volume is when you have to add. So what is the free space available here? 3 GB is left in my volume group. So what I can do here is, now suppose my database is full, okay, and I want to increase the space. 3 GB is not enough for me. I want to increase it by 2 more GB. So what I can do is LV, the command is I need to resize the LVM. So what is the LVM that is holding my database? You need to see by, okay. So this is the LVM. How to read it? This is the logical volume. Data is the logical volume name, and this is the VG name. Now I saw that in my VG 3 GB is free, and I want 2 GB to add to database. So what I have to do, I need to resize my data. That is, resize my LV to currently it is 3. I need to resize it to 5 GB. So I need to extend 2 more GB. So again, command is LV resize -L. I want to increase it by 2 GB plus 2G. Okay, and I need to give it on. I need to give the path of the LV -R path of the LV /dev/Azure data/data. Getting it? Now, once I give this, what it will do is it will resize. See here, it is resizing. Now, if I go here and do lsblk, what do you see here? 5 GB, and this one it is 2 because you did not extend. So you're getting right. What is the advantage of
Yeah,
this?
when we do this, right, existing, do you lose any data, or it's a
No.
it's a
It is without losing any data, without stopping any process, you can extend it. Okay, only thing is you should not shrink it. Okay, because while you're shrinking it, it will unmount, and it will, same command, you should be very careful. Same command, if you give -2G, okay, it will ask you to unmount, because if it has to shrink, it has to unmount it, and it has to remount, and few file system does not even support shrinking, and it is not advisable also to shrink. XFS does not support, and you should not shrink. You can shrink it. I will show you now shrinking it by 2 GB, but nobody advises you to shrink it. It is again become 3 GB because it unmounts it, shrinks it, and remounts it. So whatever process is running, anyway, if some process is running, it will not allow you to unmount also. For example, if I'm in the database folder itself, this means what? I'm using this folder, I'm doing something in this folder. Now if I try to shrink it by 2 GB, 3 GB is there, no? If I shrink it by 2 GB, it should become 1 GB, but it will not allow me to unmount also, because it's already in use. Either it will ask me to reboot, or it will ask me to kill the process which is using it. Okay, see,
Funny.
cannot proceed
I have one question.
Yes.
Hello.
Yes.
So don't we have any UI for this?
No, in Linux you cannot expect a UI for doing this. Yeah, while formatting, no, at the time of formatting you will get the screen. While installation, I did not show you the step. There you can use to decide which folder to go with and all. At the time of formatting, booting up, when you're freshly booting the VM, no, you would have seen the installation screen. When you do it this weekend, you see you can select the disk and you can format it however you want. Like swap, you can give some 2 GB, slash you can give 10 GB, and you can create one more Java folder, and you can give, well, the CL volume group is created at time of boot. So at the time of fresh format, so you can do it. While doing it, that UI you will get. I think there is UI is there. Maybe third party will be there, I'm not sure, but we rely on commands, because UI might change from Linux flavor to flavor. This is CentOS. Ubuntu you might use Red Hat in production. You might use Kali Linux, or you might use Fedora. Some variant you might be using, so you will not get a common UI for all the flavors. So if you memorize the steps on what you're doing, any flavor you should be able to work on.
So we are learning this only for installing Kubernetes in Linux, right?
Yeah, this will be helpful. See, disk management will be very helpful in case Kubernetes, Docker, in your Linux administration, Azure administration. They might ask you to spin up a Linux VM, and they might give you a structure like create these folders as LVM, this as this. So this is the basic level of what you should have understanding of how disk works, and this is very important. If you don't practice it much, you might end up losing data. like for example, if you do if you're not there in database folder and you unmount it and some process goes down. So that's why I asked you to create VMs in your laptop, and here you can practice even if you are working. Sometimes if you have to replicate something in production, you practice it in some dev or somewhere and you do it. So that is the reason we are practicing this. This will be useful. You will
Okay.
you'll
And
thank yourself that you know this later. Some point in time you're going to encounter this. Yeah.
And do you have any document listing these steps?
Steps I will provide you. Whatever we have done, I will take one history and I will give it to you, or I will try to type it and give it to you. I think I've typed in the PPT. I'll try to give that. I think this. Let me just check. Yes, I think. Yeah. I just create partition of LVM type fdisk/dv/disk name. Create physical volume pv create /dv/partition name space. You can create PVs, multiple PVs at once. SDB, SDC, SDD, and then you can create volume group with SDB, SDC, SDD, and then you can create LV out of it. But for demo purpose, I am teaching you one after another so that you understand. Mostly in production, you're going to attach a disk and increase space. So if you already have SDC, you might need to attach SDB and do it.
Okay.
Yeah. So clear, right? So we are doing where are we? LSBLK. If we do, we have database of 3 GB. We have increased it and we have decreased it successfully using LV extend. For example, let me extend it to. Let me extend it to how many GB is left? Plus 3 is then. Okay, let's plus 2 plus 4. Okay. So now DB will be 7 GB. Java. No, I don't think 4 will take. So it is not available. Extend it. So plus 3 GB. Let me do. So now my database is 6 GB and my Java folder is 2 GB. I think 3 is also not there. 2. I think does not take point. I need to give it in MB. So 3 MB will be 309. Okay, it took points. Okay, super. So if I do LSBLK, I have 5.5 GB of database, 2 GB of Java, that is 7.5 GB. Now if I do VG display, sorry, this. Okay. Now when I'm doing VG display, I can see, I don't want to see this CL. If I don't want to see all VGs, I have to give -v Azure data. Okay. Yeah. Now you can see that here, how much is free now? Just 500 MB is free. Now I got a requirement. This is the current scenario. I got a requirement saying that increase the folder space of Java because log files are piling up. Okay. Now what you have to do is you check that there is no space. You want to increase it by 2 GB. Now you have to make Java folder 4 GB, but you do not have space in your SDC. Now what you have to do, you need to attach a new fresh disk. Okay. Now let me try formatting SDB, else I will attach a new disk. Okay, because reboot takes time, so I don't want to do that. fdisk/dv/sdb1 SDB. So I need to delete the partition, create a partition, primary 111 default, yes, remove signature, D8E, okay, W. Okay, it has written it to SDB. Now PV create /dv/sdb1. I'll create a PV again out of SDB1. Okay, it got successfully created. So if I go back, what did we do now? this is our current. I think now currently it is 5 GB and this is 2 GB. I want to increase this Java volume group. Okay, now I have attached HDB and of 8 GB and I'll create a physical volume and I'll have to extend the volume group so that I can extend Java logical volume. Getting it? What we are trying to do, guys? So this scenario
we are attaching the another physical volume to the volume group, correct?
Correct. So when you face this scenario in Azure, you need to attach a disk in Azure. So we'll see how to attach a disk in Azure from UI. Here, how do you attach in Oracle VirtualBox? You just have to go to the VirtualBox menu and then attach it. I showed you yesterday, right? Same way you attach it. It went blank. 1 second. Let me just wait a couple of minutes. Let me just save the state of the machine and start it again. We can save wherever it is and it will boot it from there. 3 options we get while closing it. Either shut down, power off. Power off means it will immediately shut it down. Saving the statement to start from where it left. 1 second. So this is saved, so we start it here. Yeah. So in the settings, we should be able to attach the disk. So when you get into Linux, it is showing some. Let me boot one more VM, the another VM. This has 2 disks attached. Okay, so I can start this. Let me start that one only. Okay, by the time that comes up, let us discuss what we're going to discuss tomorrow after this. So we'll be talking about networking from tomorrow. So tomorrow, day after, mostly I'll take 2 or 3 classes on network, because this is very important. Once you, how many of you have any knowledge on networking, subnetting, classes of IPs? Anyone? Team? Anyone having idea on?
I have a little bit of knowledge about subnetting in it.
What
Okay.
network?
Sorry?
No, what network?
See, for every VM will have an IP address. Okay.
Oh, network.
Yeah, when we deploy it in Azure, we need to create VNets for each service.
Subnet.
Sorry?
VNets, subnets.
Yeah. So to understand how VNets and subnets actually work, we will go through networking basics. We will try to see what is IP address, what are subnets, what is range, class A, class B, class C. DND we don't use. So what are all these? And we'll be practicing some subnetting things, so that when you actually do work with VNets, you will have a reference of what we are talking about. Okay, so what is a network? A network is a computer
Connection.
communication between 2 different devices, okay, which happen over TCP IP protocol, and they communicate between each other. Okay, and there are different types of network. LAN, which we use in our offices or at home, we use so we can connect computers using LAN cable. And what is WAN? WAN is wide area network. We use it like internet is an example of WAN. So we use it across the globe. You're sitting here and you can access some VM server running in USA. You can access some server running in Europe. So this is possible because of this wide area network. Then we have something called metropolitan area network, which we use it within the city. If you have multiple offices within the city, for example, if you have some office 30 kilometers apart, 50 kilometers apart, and you want all your office to be connected, then you can use they call it as metropolitan area network. But these days everyone is moving to cloud, so everyone wants their VMs to be in central place, so that we don't have to go to offices to connect to our systems. So earlier servers used to be there in office, data centers used to be there in each office, and to connect to those VMs you must be there in office network. So either you have to go to office, or you can use VPN to connect to that. Okay, so let me just finish this. And campus area network, if you have one campus, it can be like you have universities, or you have office campuses which are huge. Then you want connectivity between the campus. For those purposes we use this campus area network. Basically everything is same. We have to connect everything with LAN cable. We have to use switches and routers to route traffic, and we have to design the network, how things will communicate between each other. And then we have home area network, which we use it at home, like our routers, Wi-Fi devices, etc. So tomorrow we'll see more about it. Let us quickly go and resume our LVM. Okay, so I want you to just practice LVM as much as possible, attaching disk, removing disk, different kind of scenarios, because it will be useful in your work culture. That's for sure. Okay.
Do you have do you have a list of commands?
Yeah, for LVM, right?
Yes.
Yeah, I showed you. I'll share.
Yeah, that is this thing only, right? Or is it steps?
Yeah.
But list of commands.
Okay, so how many possible commands?
Not possible commands, just the basic thing.
Yeah, I'll share that.
Yeah.
Yeah, let this boot up. So what happened? It went blank in between. Generally does not happen, but I'm not sure. Yeah. So now once we reboot it and we are here, right? do you think the Java folder that we mounted, it will still be there in Java? That LV that we mounted? And database that we mounted, will it be still there?
Those are all logical, right?
Yeah.
So,
But one thing we did not do, that is, we did not write the entry in F-step. You remember? We just mounted it and left it. We did not write the entry in F-step. You know, we used to write entry in F-step so that even after boot it persists. So now you see that it is not attached. But you can see the folders. ls/ you will be able to see database folder and Java folder, but these are not mounted. Okay. So what we have to do is now let us mount it. Let us add an F-step entry so that even after reboot we have our mount points intact. So what we have to do, we have to first get the vim/etc/fstep. Okay, here what I'll do, I'll just copy this line, boot line, yy. So you need to type yy, it will yank the lines and it will paste it. P for pasting it. Okay, yy to yank means copy, p to paste the same line. Okay, there are a lot of commands in vim itself which you can explore. Like if you give gg, small gg 2 times, it will take you to the top of the file, and if you give one capital G, it will bring you to the down of the file. Okay, and you can give escape : SENU for line numbers of the file, and then you can give :8 to go to a specific line, :9 to go to a specific line. Okay, so practice all these things in vim editor because it will be helpful when you're doing it. Yeah, so what I'll do, YYP, and I'll have to say that it is ext4 because we formatted that with ext4. For slash, I'll have to give dv/azure data/java. I think Java was our LVM name, no? LVM name was Java. So I have to give this dv azure data java, and I have to give UUID. What is a UUID? How do we get? We will get with BLK ID. Okay. Now here is the UUID for Java. For each LVM you'll get unique UUIDs which you can copy it and you have to give it in F-step. Okay. So this we have given. Now we have to give mount space -a, and one second. Isn't this? Oh, sorry. Here you have to give only Java, right? Here you have to give the mount point. Like they gave boot, you have to give Java. You don't have to give the mount space -a, and then it will be mounted. Let's be okay. Yeah, you see it. So now even if you reboot, it will be there. Okay, even after you reboot it, it will be there. Okay, one second. Yeah, now we'll do the same for F-step YYP. I'll just make that this is database folder. Okay. Yeah. So for database, I need to give this UUID for mounting it there. Copy. Yeah. So yeah, this is done. Mount space -a. We are back at the track. What I have to do now? We have to attach a new disk HDB. It is already formatted with LVM type of partition. I will have to do the I'll have to extend the VG. So VG display VG VG display, and let us see the Azure data VG. It has 500 MB. So I'll have to we have created a PV already, SDB1. So I'll just extend the VG extend Azure data /dev/SDB1. Okay. Now it will become 16 GB. So free space will be 8.5 GB because already 500 MB is free in VG. Yeah. So now if I do VG this display, you can see here free space is 8.5 GB in my Azure data. Now I can extend the Java. I'll be resize -l plus, let us make 5 GB -r/dev/Azure data /Java is my LVM name. Okay. Yeah. Now if I do lsblk, what do I see? Now Java is 7 GB, DB is 5 GB. So you can keep on doing this. You can extend one more disk. You can extend the Java partition whenever you feel like extending it. Getting it? So I want you to practice this LVM because you will come across scenario sometime sooner or later. Okay. So I think that's it. Any queries? So what did we do? We had STB. We created physical volume. We extended to. We created a volume group, and then we created a logical volume out of it. 2 logical volumes we created and mounted it to Java and database folders, and then 2 GB each. And then we had to increase it more, so we did not have space in volume group. We added one more disk. We just created physical volume and added to that volume group, and we made the volume group as 16 GB, and then we increased the space beyond. So if you want to extend even more, if you want more data, you can keep on adding disk and do this. So this is the advantage of using LVM over traditional normal disks. So you might encounter LVMs. Generally these days by default all the disk root partition is in LVM, so that if you run out of space in any VM or server, you can attach a disk and increase the CL volume group. Getting it? You can increase the root partition.
So advantage of LVM over physical volume is we can easily increase the space.
Yeah, we can easily scale up. So scaling is the factor. Okay.
Yeah.
One question: is it Kubernetes also works like this one only volumes?
No. In Docker and Kubernetes, like, see, this is purely Linux stuff. Okay.
Correct.
Now,
no concept wise.
No, concept wise I'll explain. Kubernetes is completely different. It is pods, it is containers, it is processes.
No. I'm not talking about the volumes, not about the pods and all.
Really?
Value, physical value. There also we have Kubernetes also we have values, correct?
Yeah, we have volume, we have claims, we have volume claims, but it is a slightly different concept. I will explain you while explaining that. Like, see, it will be mounted, like we will be using volume claims of base, but again, if you run out of space there, you have to increase it like this using LVM. Okay. So this concept is going to be used in many places. Wherever you run out of space in any technology, you have to increase the space on Linux machine at the end of the day. There might be any application, either you run Kubernetes, Docker, you run any application. If you run out of space, this is what you have to follow. You don't have a choice. Okay. So I want you to practice both yesterday's and today's and be very fluent with these commands, lsblk, all this. So what I will do is I'll just ping these commands, whatever are there in our group, plus I'll give few commands like is it all messed up? Yeah, try it. No, I think try it. So this PV scan.
If you don't, can you put it up in a document?
Shall I share a PDF or something?
Yes, that would be really helpful.
So where should I share? I just have to prepare it. I don't have it handy.
No, don't worry.
Tomorrow?
Yeah, tomorrow you can share it.
Okay. Okay, guys. So if you have to prepare, if you plan to practice it today, then you can just watch my video and practice it with whatever I pinged in the group. Rest tomorrow I'll share a PDF with all the possible commands that are there. Okay.
Okay. Yeah.
Okay, guys. Thank you so much.